These are the material I am going to use for making a choke to reduce the noise level in my radio. Let me see. This is an FT240 43 toroid which I purchased from a local ham. This is a plastic box recycled one. This is RG316 coax. I bought 2 meters of it. RG316 coax. It's a very thin coax. And this is nylon ties to keep the ends of these coax secure on this FT240 43 toroid. Then I'll need this connector. This is a bulkhead connector, SO239, and I'll use one of these. I want a PL259 connector. I'll take a piece of this. This is a cable which is defective. I don't know which end is defective, but I'll have to take my chance. I don't have any other here. SO239 bulk connector can be dismantled like that. You can see the main part here. This is a central conductor which I'll have to solder, and that is not that difficult. It's a nut, and this is the eyelet to which I can solder, and this eyelet can be fixed on this connector using this nut. So the usual difficulty of soldering to this bulk connector body is avoided in such a type of setting. I had shown that earlier also. I need holes for the SO239 and PL259 on either side of the box. I have drilled one on this side and another one on this side. Now I have to enlarge both of them so that it will fit correctly. Simple method which I have used is because it's a thin plastic, I have introduced the scissors inside it and rotated so that the hole will be enlarged. The hole has been enlarged sufficient for that SO239 bulk connector to go in. SO239 connector has been fixed there. I am testing out whether the nut and eyelet will go properly override, and it is okay. Now I'll have to dismantle it again and then reconnect after soldering. Now I need a piece of coax with PL259 attached. I'll cut this patch cable as I know that it is defective when I tested it once. So I presume that one half will be useful. I'll cut it into half and use each half separately and try which one will work for me. Cut it into two halves using this wire stripper. The portion where it is quite sharp I have used for cutting the coax. Using the same wire stripper, I have removed a piece of the outer jacket or protective sheath of the HLF 200 patch cable. There is one more protective layer of plastic or polythene which will have to be removed carefully using a knife. That additional layer of polythene or plastic has been removed using that knife, as you can see. Now I have separated the shield and twisted it. That's the way I usually do it for soldering, even though this may not be the ideal method. This is my method. Now you can see the dielectric coating here. This is the dielectric covering the inner conductor. Next is to remove that. Once again, using the wire stripper with carefully graded cuts, I have removed a piece of the dielectric near the tip, and now the wires inside, it is something like a stranded wire. Several multi-stranded inner conductor. Each wire has coating. Each wire has a good coating over there, maybe to enhance its conductivity. This shield also has coating. I am not sure whether it is silver coating. Anyway, it is shining like silver, likely to be silver coating. And this is not a single conductor inside, it's a multi-stranded conductor useful for RF applications. So that is ready. Checking the continuity from the shield to the PL259 connector outer part. That's fairly okay, 3.7 ohms. Checking both ends of the interconductor, that is 3.7 ohms again for a almost 50 centimeter piece of coax. Checking continuity between the inner and outer conductors, there is no continuity, so there is no short. Checking the PL259 end also in a similar way, there is no short there also. So I presume that this piece of cable with connector will be okay for me. I am going to use a nylon tie to fix one portion of the RG316 coax to the FT24043 toroid so that it will not move away. Now one end of the RG316 has been tied using the nylon tie. I'll have to nip off the extra portion. Extra portion has also been nipped off. One more nylon tie has been used to anchor it so that it is almost fixed. It will not come off easily while winding. This should not slip. That's the reason why you are using this nylon tie, because the RG316 coax can be a little slippery while winding. That's why I fixed it. This has been described in some of the blogs. I started winding the RG316 coax on the toroid. Being the first time I am attempting this, I don't expect much perfection. The condition is that the turns should not be too near each other so that inter-turn capacitance can offset the use of this choke. From the 11th turn, I have to cross over to the opposite side. So I am again locking it as described in the other blog for prevention of slipping of the coax. Now the second set of 11 turns after crossing over to the opposite side has also been completed, and I have secured it with a nylon tie.